For my after the exam project number 3, I will be demonstrating how to determine the pH of a polyprotic acid solution. The polyprotic acid we will be working with is carbonic acid, which can be produced from the combination between carbon dioxide and water. It is assumed that all of the CO2 has dissolved in the form of carbonic acid. The solubility of CO2 in pure water at 25 degrees Celsius and 0.1 atmospheres is 0.0037 molar. This is the assumed concentration of the carbonic acid solution. We will be determining the pH of this. In order to solve this problem, we must make an ice box. Over here, we have the initial concentrations, the change in concentrations, and the equilibrium concentrations. The equation for the first dissociation of carbonic acid may be written here. From carbonic acid yields a hydrogen ion and a bicarbonate ion. The initial concentrations of the H plus and HCO3 minus ions are 0. We know that the initial concentration of the H2CO3 is 0.0037 molar. The H plus and HCO3 minus ions change X, and the carbonic acid is subtracted X. The equilibrium concentrations then are 0.0037 minus X for the carbonic acid, and X for the hydrogen ion and the bicarbonate ion. The expression for the first dissociation of carbonic acid is the concentration of the hydrogen ion times the concentration of the bicarbonate ion over the concentration of the carbonic acid. We can substitute in the values that we got for the equilibrium concentrations. The known value for the acid dissociation is 4.3 times 10 to the negative 7th. The X value in the denominator is so small that it is negligible. We will prove this later. We get X squared over 0.0037 equaling 4.3 times 10 to the negative 7th. Thus, x equals the square root of 4.3 times 10 to the negative 7th times 0.0037. We can plug this into a calculator. And we get 3.988 times 10 to the negative 5th. This value is rounded to 4.0 times 10 to the negative 5th molar. And this is the concentration of the hydrogen ions and the bicarbonate ions. pH can be calculated by taking the negative log of the hydrogen ion concentration. We can plug in 4.0 times 10 to the negative 5th for the hydrogen ion concentration. Using a calculator, we can determine that the value of the pH is 4.40. We may now use these values to determine the concentration of the carbonate ions. To do this, we must make another icebox. The dissociation reaction can be written as bicarbonate yielding a hydrogen ion, and a carbonate ion. From the previous work, we know that the concentration of the bicarbonate and hydrogen ions is 4.0 times 10 to the negative 5th. The concentration can be written here. The concentration of the carbonate ion is 0. We can use a different variable for this icebox, y. The change is plus y for the hydrogen ion and carbonate ions, and minus y for the bicarbonate concentrations. The equilibrium concentrations are 4.0 times 10 to the negative fifth minus y molar for the bicarbonate and 4.0 times 10 to the negative fifth plus y molar for the hydrogen ions, and y molar for the carbonate ions. The second acid dissociation can be written as Ka2 equals the hydrogen ion concentrations times the carbonate ion concentration over the bicarbonate ion concentration. The values can be plugged into this. The known value for this is 5.6 times 10 to the negative 11th. Again, the y is negligible in the denominator. The y value comes out to be 5.6 times 10 to the negative 11th. Since the numerator and denominator values can cancel. Since the y value is 5.6 times 10 to the negative 11th, this proves that the concentration does not need to be taken into account when finding the pH because it is so small. And that is how you determine the pH of a polyprotic acid solution. Thank you for watching.